everyone, what's up? All good? Great. Today we will be solving the question product of array except itself. So let's see what is this question saying. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. Okay. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Okay. You must write an algorithm that learns in O of n time without using the division operation. Okay, so that comes in the optimization part as well. So we will see the question from the scratch that how we might think from brute force to optimal. Okay, so let's see first what is this question saying. We need to return an array answer such that answer I is equal to the product of all the element of nums except nums I. Okay, so let's see. Here you can see that answer I is what? Product of all the element except one. 3 multiplied by 2 multiplied by 4. Okay, so let's see. Answer of I, it means answer of 1 is equal to multiplication of all the elements except 2. That is 4 multiplied by 3 multiplied by 1. So we need to return this answer array in which answer I is the multiplication of all the elements except nums I. Okay, so let's see how we can solve this question. Okay, so first of all, we need to iterate to each element of nums, right, for finding its product. And then we can simply iterate this again to find all the product of all the elements except when I is not equals to 0. Let's say I will run a loop for I is equals to 0 to n and then declare a multiplication variable equals to 1. Okay, then again I start iterating in that array and then check if I is not equals to j, then I will simply multiply that element in my multiplication. Okay, and then at the after coming out of this loop, I can simply update our my result of I to multiplication. Yeah, so simply we can simply iterate in our array and then find the multiplication of all the elements of the array except when that element is equal to the that element. Means when we don't need to calculate the product of that element. So whenever I is not equal to 0, we will be calculating the product and we'll be returning our result. Simple. So now what will be its time and space complexity? Its time complexity will be big of n square. As you can see, we are running two nested loops, and its space complexity will be big of 1 as we are not using any extra space. Okay, fine enough, but not because n square will not work in terms of the constraints given and will also not work in your interviews. As you can see, where the constraints is 10 to the power 5. Okay. So let's see the more optimized approach, how we can do this. Okay, so what we can do is we are given within nums. Okay, so can as in the question it is mentioned that don't use the division operator. Let's try using that as well. Okay, so let's see if we have pre-computed the result of all the multiplication of all the elements of the num side. So let's see what will be that result. 1 multiplied by 1 multiplied by 2 multiplied by 3 multiplied by 4. Our nums is 1, 2, 3, 4. Okay. So now, what we can do is, if we have pre-computed its result, now we start iterating on the nums again. Okay. So now, whenever we are at nums of I, we will be dividing this pre-computed result by 1. Okay. Now, the product of remaining elements will be our result of I. Okay, now when we come at 2, we will just divide the pre-computed result by 2. Now the product of remaining elements will be our nums result of I. Yeah, cool. So we can pre-compute the result of all the elements of nums, and then whenever we are at some element, then we will divide the pre-computed result from that element, and we will get our result of I. Okay. So will this approach work for all the cases? Okay, so let's see. What if we have zeros right here? So our pre-computed multiplication will be 0, right? So now whenever we encounter at this element, we will be dividing this pre-computed result by 0. And what will it give? It will give us a runtime error, which is division by error. Sorry, division by 0. So it will give us a runtime error if we use this division approach. That's why in the question it is mentioned that you should not use division, because you can also have 0 in your arrays. And here you can see that it will give us infinite or division by 0 error, but here it should be 9. So this division approach doesn't work. But its time and space complexity are much better, because we are just running one loop, so its time complexity will be big of n, and we are not using any extra space, its space complexity will be big of 1. So this approach will work only in the case when we don't have zeros in our array. Okay, so now we have zeros, so this approach will not work. So let's see another way of for optimizing this. Okay, so we have an array. One, two, three, four. Right. Okay. Now you can see at one what we need to give us as output. We need to give us the product of these elements. Okay. So this will be 24. Now at two, what we need to give as output? We need to give the product of these and this element. Okay. Now at 3, what we need to give as output? The product of these and this element. So you can see we need to give as output the product of all the elements of the prefix of that element and the product of all the elements to the suffix, or we can say the product of all the elements present on the right of that element and the product of all the elements present on the right of that element. Okay, can we pre-compute these products? Like if we just need the product of left elements, then we can pre-compute that product. Or similarly, we can pre-compute the product of all the elements present in the right. Okay, so let's see. Can we do this? This is not sounding like prefix and suffix. We need the product of prefix elements and suffix elements. So okay. So let's try making prefix and suffix array. Okay. So as it doesn't have any prefix, so let's keep it blank for now. Now, for this, the product of all the elements present on the left. Okay, so it will be 1. Now, for this, the product of all the elements present on the left. So what it will be? It will be, let's say it's I is equals to 2. So, I minus 1, nums of I minus 1 multiplied by prefix of I minus 1. So it will be 2. Now for this, similarly, nums of I minus 1 multiplied by prefix of I minus 1. Okay. So now, but this doesn't have any prefix. So what we should keep here? Can we keep 0? No. When, what, why? Because if we start multiplying 0 by 1, then it becomes 0. Then we should keep a number that should not affect our answer. Okay. So whenever while we are doing multiplication, what is the number that doesn't affect our answer? That is 1. Cool. Similarly, we can start making our suffix array. As 4 doesn't have any suffix, so we can keep it blank. Now starting from the 3, it will be 4. 4 multiplied by 3, 12 will be the suffix of 2. Now for 1, 24, 12 multiplied by 2. Similarly, we can keep 1 as a default value for here. Now, what we need to do? Our output will be result of I will be prefix of I multiplied by suffix of I. product of all the elements present on the left and product of all the elements present on the right. You can see 24, 12, 8, and 6. Yeah, we have got our answer by pre-computing the result of products of elements to the right and the left. So yeah, now what will be the time and space complexity for this one? As first loop we are iterating for finding the prefix array, then another loop for suffix array, then another loop for finding the product of prefix and suffix. So it may be big O of 3n or we can just say big O of n. And what will be its space complexity? As we are using two arrays, that is prefix and suffix, so its space complexity will be big O of 2n, or we can simply say big O of n. Okay, so let's see its code. See here, I have declared two prefix and suffix array initialized with the 1 and then computing the prefix array and then computing the suffix array and then simply computing the product of prefix and suffix of I and then finally returning our result. Okay, cool. But this exchange space of big O of 2n is not looking good. Can we optimize this space? Okay, so let's see if we can optimize this space. So we have nums 1, 2, 3, 4. Okay, very good. So as the output, the result of the output space will not be calculated as an extra space. Okay, so can we use that space for now? Because initially we are just computing the result of prefix and suffix array, right? And our output array is empty. So can we use that space for computing their results? Yeah, we can. Okay, so let's say initially I will be considering this output array as my prefix array. So what will it become? It will become 1, 1 multiplied by 1, that is 1, 1 multiplied by 2, that is 2, 2 multiplied by 3, that is 6. Okay, so let's say I am initializing our output vector with my prefix. Okay, but now what about suffix? Okay, what can we do with the suffix? Okay, so what is in suffix array? Suffix array is just the com just computing the product of all the elements from the right? We are just computing all the product. Nothing, just nothing doing anything else. Okay. So let's say if I'm initializing my suffix variable with 1. Okay. Okay. So whenever we are at 1, we are at this element. Our suffix is always 1, right? Okay, I will just initialize the array. What was my suffix array for your understanding? It was 1, 1 multiplied by 4, 4 multiplied by 3, 12 multiplied by 2. Okay, so this was my suffix array, but for now we are not using it. I have just initialized it for your understanding. Okay, so now initially my suffix is 1. Okay, cool. So what I can do is I can parallelly compute this product and then parallelly multiply by this product in my result so that I don't need to store this suffix value in my another suffix vector. Yeah, we can do this. Let's see how. Okay, so initially I will initialize my suffix with 1. So we don't need to do anything with the last element because it will be only that element because it doesn't have any suffix elements. Okay, let's see. So for now we are at this index. Okay. So at this index, what we were we doing? We were doing that multiplying our suffix with this. Yeah, so our suffix will become now 4. Okay. Now how we can update our output? We can just update our output, that is result of I is equals to result of I multiplied by suffix. See, so what we can write here is 4 multiplied by 2, that is 8. Yeah, cool. Now for the next step, what our suffix becomes? That is 4 multiplied by 3. Yeah, right. So that will become 12. Now what we will be doing for with the result? we will be doing result of I multiplied by suffix. So 12 multiplied by 1, that is 12. Now what our suffix become? 12 multiplied by 2, that is 24. Now what our result of I becomes? Result of I multiplied by suffix, that is 24. So yeah, we don't need to store all the product of suffix elements in a separate vector. We can just simply parallelly compute the product of suffix elements and then simply multiply it with them with the product of prefix elements. So what we have done here is we are just simply iterating in our array and then, sorry, not from 0 to n, it's n minus 2 to 0, okay? And then simply computing the suffix by suffix multiplied by nums of I plus 1 and then updating our result with result of I multiplied by suffix. That's all. Yeah. So now what will be its time and space complexity? As you can see, we just need to uh, do one iteration for computing the prefix array and then again updating our output. So it will become big O of 2n or we can say big O of n. And now we are not using any extra space, so its space complexity will become big O of n. Sorry, big O of 1. We are not using any extras. Cool. So let's see what's will be this exact code. So here I just forgot to remove this prefix and suffix vector. You just remove it because we are not using it now. So here we are just declaring our result vector, we initializing it with 1 and then using that result vector as a prefix array and then initializing a suffix variable. So finding the product of suffix element and then updating our result and then at the end we are just returning our result. So its time complexity will be go of n and space complexity will be big of 1. Yeah, so we have done with this question. So this was very intuitive question for the prefix and suffix array, but if we came to optimize the space, it will become a little bit tricky, but I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.